All right. Hello, everybody. Let me just share my screen here. And if this could just start. I hope you can all see this. Welcome. My name is Alex Babeanu. I'm an identity solutions architect with Nolly, a consulting firm based in Canada, but we do lots of work internationally. So welcome to Identiverse. So anyway, we're at an identity conference, and so I'm sure that a lot of you at least have one of these, a cryptographic key. Right? I would love to see a show of hands, but unfortunately I can't see you. But please feel free to share your experience in the chat. Now, if you do have one of these, have you ever tried to convince a family member to use them? I have, and my experience is as follows. When I tried to convince my wife, she stopped listening to me after about the second sentence. My daughter, though, she's a good sport. She tried it out. And after a few months, I asked her about her experience. And the only thing she said to me then, and I quote, was, "It's so annoying." And she's right. For the most part, MFA has failed us so far. So this is what I'm going to talk to you about today. We're going to have a look at the problem with the user experience in our universe right now. We'll have a look at user journeys and what they are. We'll need to talk about friction because that's kind of the root cause of all our problems, really. We'll have a look at the solution and how to implement it. Great, let's get started. So first of all, what is the problem and why should we care? Right now, we need to toggle with two really opposing forces. On the one hand, we have users that want an easy and good experience, and on the others, CISOs that want a secure environment. And as we'll see, it is really hard to reconcile those two opposing forces, really. So let's have a look at first the user experience and see what the problems are there. First of all, we need to understand that bad user experience comes at a really high price. These are just some stats I found online, find references on the page here. So the first thing that is quite interesting to note is that 45% of users give up registration if it's too hard. And now the bar there is set really low. Most things are too hard, interestingly. The other thing is that there are some really horror stories about bad user experiences. For example, Marks and Spencer's lost about 55 million British pounds because of poor self-service UI that was crashing all the time. And Walmart lost a staggering almost 2 billion US dollars because of a poor website redesign. That's just bad UX. Another telling statistics that dates back from 2016 was 4.6 trillion dollars were left in online shopping carts for uncompleted transactions. 25% of those have to do with creating a user account. That is $1.1 trillion that is directly attributed to something that we, identity professionals, do, creating user accounts. We have to do better than that. And if you're in the enterprise world, still the #1 tech support call is forgot password. So quite telling, this is all bad user experience and it comes at a very high cost. Okay, but security is also important, right? Of course it is. Last year was the worst year on record for data breaches. More than 36 billion records were exposed worldwide in over 3,000 to almost 3,000 breaches altogether. I jotted down here on the right some stats for the number of compromised records just in 2020. We find here Facebook, Microsoft, Barnes & Noble, etc. Chances are our record has been compromised last year, sad to say. But data breaches come at a monetary cost as well. On average, worldwide, $3 million per data breach. In the US, which is the most expensive country, it's about $8.6 million. Healthcare is the most expensive industry for breaches, and the number there is $7 million. Again, this is monetary. It doesn't account for the loss of reputation or the impact on those people whose records have been breached, but still quite tremendous. So as you can see, we need to juggle with user experience on one hand and security on the other. Not easy to do. So how do user journeys fit into that? User journeys are the quest for user satisfaction, which is sometimes akin to putting that ring into that volcano over there. So what is a user journey? A user journey is the experience of a person has when interacting with something. That something could be a web service, a device, a website, whatever it is. Let's have a look at an example. Here's Lizzie on the left here. Lizzie is shopping for a dress online. And as we'll see, Lizzie can have a positive experience or a negative experience when she does that. This is her overall user journey, starting from the search, the discovery, and the purchase. She first starts to search for a dress online, but discovers that she has a limited budget and can't find her size. Pain points. She refines her search, but there aren't many listings. She doesn't find many options, and she needs to contact the store. Now, there's a really long wait time on the store. Really, that's painful. But eventually, she hears back from the store, likes the price and the item, and buys. Now she's happy. This is the overall journey for Lizzie. But as identity and access management professionals, our impact on Lizzie's journey is actually quite small. It would happen maybe at the end, right there, when just before she purchases. But as I mentioned earlier, that impact, even though small, is very important because this is the point when most users will probably just abandon their purchase. Now, from a user journey's perspective, our impact as identity and access management professionals has to do with self-service, authentication, and authorization. So let's have a closer look at why Lizzie has those pain points. What are those pain points really? The pain points are all caused by friction, and we need to understand friction better in order to better the user experience. So friction is anything that prevents a user from accomplishing a goal in your product, service, or device. Anything at all that stands between what you sell and the user. There are actually three types of friction. There is interaction friction, cognitive friction, and emotional friction. Let's have a deeper dive into these because it's really important to understand. First, interaction friction. It results from interactions with the UI. The factors there are the number of fields or steps in your forms, consistent UI styles, the complexity of your UI widgets and their placement, etc. Some examples here are Slack versus email. Email being asynchronous, you have to type in these long sentences, wait for an answer, versus Slack, immediate, much easier. Or for us, login forms or authentication factor UI widgets. Those all take part into interaction friction. Cognitive friction has to do with the cognitive load or the total mental effort required to achieve a task. The factors there are the complexity of the task, the number of tasks, and the number of devices you have to use in order to accomplish the task. Some examples, Uber versus taxi. A taxi, you have to go outside, hail a taxi, wait, and then eventually pay at the end of your trip. Compare that with the Uber experience. For us, multi-factor authentication, setting up and using external devices can take more cognitive load. Finally, emotional friction arises from the emotions felt by users that prevent them from accomplishing a goal. And typically those emotions are fear of something, fear of failure, fear of errors, fear of doing something wrong, fear of rejection. Some famous examples, Facebook's emotional friction of sharing, because whatever you share there is there forever. So people are scared of sharing, versus Snapchat, which are self-deleting snippets that leave no trace. Much easier to share in that case, no lasting impact. Or multi-factor authentication, which causes confusion and fear of errors. I've seen this firsthand, so I know exactly that is actually quite true. So let's have a look at how our factors of authentication affect user experience. There's a very interesting table here. We have our methods of authentication on the left and their impact on security and user experience. So SMS OTP, no impact on security. I mean, it's not very good at all. Poor user experience. Overall, pretty bad. If you do SMS OTP, you gotta move away from that. It's bad on all fronts. OTP push, better on security, still bad user experience. Security key, great security, bad on user experience. I mean, you always need to have that key with you, which was my daughter's complaint. When you're traveling, when you're using your phone, not easy. Biometric factors are not as good for security, but better for user experience. And this is our nirvana, really, behavioral biometric factors. These are factors that use scores or risks based on users' behaviors or habits or context. There are no impact on user experience because the user mostly doesn't know they are there. They're completely transparent. So I'm hoping we can see more and more of these going forward. So as you see, we have to juggle between user experience and security. Not easy. What can we do? How do we do this? Well, we need to introduce user journeys for IAM as well, specifically for IAM. So for that, we want to focus on two main things: user self-service and authentication and authorization. Let's start with user self-service. So the first thing that users usually do is register, or you need to onboard new users. The first thing you need to do is avoid those big one-step forms for registering users. Here's a particularly bad example of that. This form here has a lot of friction. There's some interaction friction because there's a lot of fields and lots of buttons. Maybe even some cognitive friction because now you have this strong thing here. And everything here is mandatory as well. Definitely avoid that. People will just give up. They won't even try. Instead, favor progressive user profiling, which can start with logging in with a social provider. This enables you to create a basic user account, lets the users in, and they can use your product, service, or device. If you need to capture email and password, then do it in 2 steps. And later, much later, capture the other stuff you need, the addresses and whatever it is. You only need to capture that at the very last moment, maybe at the moment where the user makes a purchase or tries to use the service. So that's called progressive user profiling. Much better, less friction. Great. How about authentication? Well, authentication, some rules. First of all, recognize that most authentication factors have friction, as we've seen. So each additional factor in MFA adds friction, and we need to reduce the friction to the least amount possible. Lastly, one size does not fit all, and this is where we'll spend most of our time now, is to recognize that not all our resources need to be protected the same way, and shouldn't, because we need to minimize the friction. How do we do that? Well, here is a methodology, some high-level steps. First, you need to identify the security risks for every one of your resources or apps. Second, you need to identify proper security controls for these resources and apps based on those security risks. Then you need to request only the necessary control from the user and only perform step-up authentication as necessary. We'll deep dive into each one of these points to understand them better. So point number 1, we need to identify security categories for your application, resources, or APIs. So in essence, this boils down to answering this question: what is the risk of exposing a given resource or data? What's the risk? So the goal here again is to assign security categories to your apps. And how do you do that? Well, first, if you're in a big organization, you might already have some internal standards for data confidentiality. In fact, you might already have had to take an online training course for that within your organization. If you do, if your organization has such standards, well, use them. If not, well, you don't have to reinvent the wheel. We can ask NIST, the National Institute for Standards and Technology. They've actually already given us all the direction we need in a series of publications, which I'll go through briefly with you now. The first one of these, SP 860, defines some security objectives that you can that you can use for your applications and resources. Let's focus just on the headers here. There are 3 main security objectives that NIST defines. The first is confidentiality, is ensuring that only the right people can access confidential data. The second is integrity, only the right people can modify that data. And availability, ensuring that the data is available when needed. For each one of these objectives, NIST defines 3 levels of potential impact of a data breach: low, moderate, or high. High being severe or catastrophic, and low, limited. Great, so this is what we try to achieve. Last, in another publication, NIST defined the security categories as being the combination of these scores of confidentiality, integrity, and availability. Here's an example. Public data on the website, the security category for that would be, from the confidentiality perspective, not applicable. I mean, it's public data, but the website needs to be available and the data on there needs to be accurate because it reflects your company to the outside world or your organization. So the goal then is to take every one of your resources or apps and devise a security category for them. Now, if you're in a big organization, you might have hundreds or thousands of apps or resources to protect. You don't have to do this all on your own. In fact, this is where you would delegate that task to the resource owners or to the application owners. They should calculate or give you the security category of their own resources and apps. Great. Number two, we need to define the proper security controls for the security categories. And this is the core of it. This is where we see that one size does not fit all. We don't need to protect super confidential data the same way as public data. Finally, we need to find the right security control, and this provides us with a list of available controls. We can focus for identity and access management to access controls AC1 to 25, which have to do with authentication and authorization. So now we have a list of security controls that are adequate for our security categories, which leads us into the last NIST publication here, which is the assurance levels of each authenticator. So this is where we see that single-factor authentication is assurance level 1. Assurance level 2 is two-factor authentication that involves cryptographic techniques, things such as push authentication, OTP, etc. Level 3 would be hard crypto authenticators, such as the keys I mentioned earlier. What I see missing here is those famous adaptive and behavioral factors. They're not there, which is quite bad, too bad actually. I hope this will come up with an update, but I think this should be added in there. Now, depending on how comfortable you are with those adaptive or behavioral factors, they could be level 4, or you can insert them between the other ones. So how do we bring this all together? Let's do this. Let's bring it all together and create our user journey. Here's an example of a user journey that starts from registration to authentication and authorization. So let's see our user here. It's a swim lane, so we have the UI at the top and the backend service or the server side at the bottom. So the user first comes to our service or website or whatever it is and starts by registering through Google. They log in through Google, so we can create a basic user profile and we're done. So then the user logs in, we capture the login info, and they're trying to access a resource. So at that point, we try to evaluate the security category of that resource. Based on that security category, we determine the required assurance level, the authenticator assurance level required to access that resource, and we challenge the user with the right authenticator. The user then performs the authentication, and we create a session, and we set the authentication assurance level on the session. Great, the user has a session and has accessed the resource. Later on, the same user tries to access another resource. At that point, we again evaluate the security category of that new resource, and now the user already has a session, so we can compare the level of assurance they have already achieved in the session with the one required by the resource. If the session's assurance level is greater than or equal to the resources, then we can grant them access. Otherwise, we need to determine the right authenticator assurance level for that resource and challenge them with that. And this would be your step-up authentication. At that point, the user has we need to upgrade the user session and set the new assurance level on that session, and the user accesses the resource. And that's it. What we have achieved here is that we've ensured that the users only need to do step up or use those complicated factors when they really need to. And as you'll see when you start using this, is that only a subset of your users actually need to do this. So most of your users will just simply log in simply and access, not as confidential resources. And that's exactly what we need to achieve. So to recap what we've talked about, first of all, use progressive profiling. Always assign a security category to all your resources. Request only the authentication factor necessary for the security category. Favor adaptive behavioral factors and enforce step-up when needed. Now, the adaptive behavioral factors, I'm sure they're still in their infancy. I mean, there's some things that I've heard exist using things like mouse movements and keyboard strikes and things like that. I'm hoping we'll see more of those. In any case, that's all I had for you today. Thank you for listening, and I'll be happy to answer any questions you might have. I'm not sure actually how I can do that. I can't